Welcome to a new AG session all about analytic geometry. This time we are going to prove that the given points A with -4, -1, B at -2, -3, C 4, 3, and D 2, 5 are vertices of a rectangle. Now let's try to illustrate these points first on this Cartesian plane. Of course, we know that the horizontal axis is our x-axis and the vertical one is our y-axis. Let's consider as well that each grid here is per 1. Therefore, we have these points. Let's start with A, -4, 1, 2, 3, -4, and -1 here. So this is our point A at -4, -1. B is at -2. We have here -2 and -3. This is our B, point B. Point C now is at 4 and 3. So 1, 2, 3, 4, 1, 2, and 3. So this is point C. Okay. And our point D is at 2 and 5. 3, 4, 5. 1, 2, and then here. This is our point D. If we are going to connect these points by following the ABCD format, we will have this here, the segment. Okay, assuming that my graph is accurate, you have it here, and then you will have it here, and here as well. Again, my graph may not be that accurate, but this for illustration. So we have here a quadrilateral, okay? But here the point is to show that this is a rectangle, and of course A, B, C, and D are vertices of a rectangle. Now, before we proceed, we could attack this in two different ways. One of the ways that we could use here is the idea that if this is really a rectangle, the opposite sides are of the same measurement. Okay, because rectangle is a parallelogram. Now, we have shown in the previous video, please check that one before going here. We were able to show that a certain set of points are also vertices of a parallelogram using the concept of length of the sides. Okay, but in that video we could also use the second method I'm going to present in this video, but we specifically used the length of the sides in that previous video. So I'm not going to show the proving of this using length of the sides. I want you to check the previous video on showing the vertices of a parallelogram. But here, we're going to attack one of the important concepts if this is really a rectangle. That is, these are forming 90 degrees. Okay, that's one of the unique concepts for a quadrilateral named as a rectangle. Aside, of course, from the opposite sides that should have the same measurement. So side AB here should have the same measurement, side CD, and then side DA is also have the same measurement with side BC. Again, I'm not going to show that the concept of lengths. I want you to check the previous video. Here, we're just going to show using the concept of the 90-degree angles here. And the 90-degree angles is closely related to the term perpendicularity. In short, what we're going to show in this video is to show that this line segment is perpendicular to this and here, and this line segment is also perpendicular to the others, and these smaller sides are also perpendicular to the longer sides. And when we talk about perpendicularity in the Cartesian plane, we can use the concept of the slopes. Aside from perpendicularity, the other description of rectangle is that it's a parallelogram. Okay, rectangle is a parallelogram together with square and together with rhombus. All three of them are parallelogram. In short, these opposite sides, aside from being or having the same measurement, they also have to be parallel. All of these two, perpendicularity and parallelism of lines, can be determined to us by the concept of the slope. The slope can be solved as the change in y sub 2 minus y sub 1, over the change in x. So again, in the previous video where we use the lengths in showing that the figure shown or formed by 4 vertices is a parallelogram, we use the lengths. this is, we can also use the lengths here, as this idea of slope could also be used in that previous video, but we separate it into different contexts. So let us try to show the slope of each. So we're going to solve for the slope of AB, the slope of BC, then slope of CD, slope of CD, and then the slope of DA or AD if you would like to. Okay, and let's look at the relationship. We need to show that the slope of AB and CD or DC should have the same values, that they are parallel. Together with DA and BC, they also have the same slope for them to be parallel, and that the slope of the longer sides against the smaller side should be perpendicular in terms they are actually what do you call this one, negative reciprocals. So again, the slope for two lines to be parallel, we have this, and for two lines to become perpendicular, we have this measurement. So let's start now. AB, let's pick B as our second point. That would mean it contains x sub 2 and y sub 2. So y sub 2 is negative 3 minus y sub 1, that's for our A. Don't forget to enclose it in parentheses. Over our x sub 2, which is negative 2, over our x sub 1, which is negative 4, again enclosed in parentheses. It's okay if you will pick A as your second point and B as your first point. Just make sure that the y sub 2 and y sub 1 will be interchanged together with x sub 2 and x sub 1. So you will have here negative 3, double negative property, that's plus 1, over negative 2, double negative property, plus 4. So your slope here is 3, we have negative 2 over positive 2. So the slope of the line segment AB here is equal to negative 1. Okay? Now let's proceed to the next one. BC. Let's just simply solve all of them first, and let's connect to this relationship later. So let's pick C as our second point. So our y sub 2 is 3. Our y sub 1 is negative 3. So you have here minus negative 3. Over x sub 2 is 4. Minus our x sub 1, which is negative 2. By double negative property, that's a 3 plus 3. Our denominator is 4 plus 2 equal to, this is 6 over 6. The slope for segment BC is equal to positive 1. Okay? CD, we'll have D as our second point. So our y sub 2 is 5. Minus our y sub 1 for C, which is a 3, over our x sub 2 is 2 for D, and for C we have minus 4. This is positive 2 over negative 2. The result here is negative 1. And then you will have here for DA, let's have A as our second point. Y sub 2 is negative 1 minus 5 over our x sub 2 for our A is negative 4, okay, minus our x sub 1, which is 2. So you have here, that's negative 6 over negative 6. The result is positive 1. Surprisingly, all of our results for our slopes are integers. If they are fractions, so you still need to analyze the same way we're going to do it right now. Now, let's pick segment AB. The slope is negative 1. DC here, the slope is also negative 1. We can see that the slope for segment AB and CD are the same. In short, they are parallel to one another. Okay? The same goes with BC, positive 1, and DA or AD, which is positive 1. They also have the same value, so they are both parallel as well. With this idea on hand, okay, this is already a parallelogram with that idea because we have satisfied that the opposite sides are parallel. Now, aside from that, that's just an indication that this figure is a parallelogram, but our proving here is for rectangle. The first idea of showing slope using this idea can be captured if this is only proving on parallelogram, but still we are talking about rectangle, means we need to show they are perpendicular to one another. Let's just simply pick one or two pairs. We have AB here. AB is -1 and BC, which is 1. Are they negative reciprocals to satisfy that they are perpendicular? Let's try. If we're going to reciprocate this, of course, we know that it's over 1. So we could have 1 over -1. And negative of that, negative of the reciprocal. Negative, negative, that's positive 1, which is the same as this value. This means that AB and BC, or segments AB and BC, follows the idea that their slopes are negative reciprocal of the other. In short, AB, or segment AB, and segment BC are perpendicular to one another. Hence, it's true that this is really 90 degrees. Same thing with CD and DC here. Okay, -1, same concept here. They are also perpendicular, so this is 90. And we know the idea that for a quadrilateral, the sum of the interior angles is equal to 180 degrees, and the opposite sides have the same angles, or opposite angles have the same measurements. So we also have this 90 and 90 here. Or if you don't want that idea, let's have BC, this one here, and CD. Let's show if this is really 90. So if you're going to reciprocate this, we have 1 over 1. So it's still 1 over 1. And the negative of that, negative reciprocal as mentioned, if it turns here. So that would mean that these 4 angles here are 90-degree angles because they are the sides corresponding to that angle are perpendicular to one another. So we have already shown as well that these are 90-degree angles and they are perpendicular to one another, the sides corresponding them, and that the opposite sides are also have pairs of opposite sides have the same measurement. This shows that our figure here is a rectangle, and that would mean points A, B, C, and D are vertices of a rectangle. Thank you for watching, and stay tuned for another session here in AG for Analytic Geometry.